Which of the following will increase in a state of hypoxia, which occurs when there's low oxygen levels, specifically in the tissues, which are usually caused by hypoxemia, which is low oxygen levels in the blood? So option A is saying erythropoietin. And in terms of if erythropoietin, will this be increased in a state of hypoxia? So erythropoietin happens when there's an increase in the production of red blood cells. And now, if there's low levels of oxygen in the blood, then we would need to do some sort of compensation in the body to make up for this. And by having an increased amount of RBCs, or red blood cells, this would help to improve the delivery of oxygen, which would be a way to compensate for these low oxygen levels that we see in the hypoxia. And therefore, an increase in erythropoietin would be something that we would expect to see to increase in the state of hypoxia, because it would be increasing in response. So it wouldn't be directly like because there's hypoxemia or hypoxia that would cause, that specifically causes an increase in red blood cells, but the body then would create more red blood cells in response. So the order would be low oxygen, which stimulates the body to compensate, which then would cause an increase in RBC production to help compensate for this situation, which would be erythropoietin is what we would see as a result of that. Increase in RBC, increase in erythropoietin. So option A is looking correct, but let's take a look at the other choices as well. So option B would be incorrect when it's saying firing of carotid baroreceptors, because the baroreceptors help to sense changes involving blood pressure. It wouldn't be able to sense any changes with oxygen levels, such as hypoxia that we see here. So for this question, for which would increase during a state of hypoxia, the firing from the carotid baroreceptors would not be the correct choice, so we can eliminate option B. Option C says the production of ATP. Yet in this example, we would need the oxygen levels to be higher at normal levels in order to produce ATP or energy. So O2 would be needed to make energy, and because it is decreased, we wouldn't see an increased production of hypoxia. We would see a decreased production of ATP during a state of hypoxia. And the reason that, even though in option A you might think, oh, but we had erythropoietin increase as a compensation mechanism, could the production of ATP also be a compensation mechanism? However, we wouldn't have the means to create ATP at this moment in the body being in this current state, so we couldn't increase production of ATP just suddenly as some sort of compensation. We wouldn't be able to do that, so we could eliminate option C. And in option D, insulin sensitivity, this would be through a different process, anything involving insulin and blood glucose levels. However, you could see a decrease in the ability for glucose to be transported and the ability to create ATP, as we discussed in option C, because the low levels of oxygen in red blood cells would make it difficult for the glucose to be transported. So that would be the relation to that body system. However, when we see in option A, the increase in RBCs as a compensation mechanism, hopefully once that occurs, then there will be better transport of blood glucose as needed. But for this question, insulin sensitivity would be incorrect. So option A, erythropoietin, would increase as compensation mechanism in a state of hypoxia. So option A is correct.